Regents Review, January 2018. This video's guest of honor, back by popular demand, the Drake. A manager wanted to analyze the online shoe sales for his business. He collected data for the number of pairs of shoes sold each hour over a 14-hour time period. He created a graph to model the data as shown below. The first part wants us to know why the integers would not be an appropriate model. Well, the time is in hours, and we can't have negative hours. Also, our set of y values, or our number of pairs of shoes sold, can also not be negative. So he is incorrect. Since we cannot have negative time. I specified time because time is the domain, the x-axis, or the t-axis in this case. Next question asks us to state the interval for which the number of pairs of shoes sold is increasing. We know that increasing means we're going up from left to right, so this portion of the graph here is increasing, and that is from the t-value 0 to the t-value 6. So I can represent my answer two ways. I could either say 0 to 6, or I could say from 0 to 6, the time in between 0 and 6, although I do not want equal to in my increasing and decreasing intervals. For the same reason, I have parentheses here instead of brackets. Finally, determine the average rate of change between the 6th and 14th hours and explain what it means in the context of the problem. So the average rate of change is going to be our formula y2 minus y1 over x2 minus x1. And we want the 6th and 14th hours. So we have the coordinate 6, 120 and 14, 0. So my y values, 120 and 0, I'll subtract in the numerator. My x values, 6 and 14, I'll subtract in the denominator. So from here I have 120 divided by 6 minus 14, which will be a negative 8. And 120 divided by negative 8, we'll need a calculator for that. At least I will, just to make sure we get it right. Will be 15. Well, negative 15, since our 8 is negative. So our average rate of change here is negative 15. And to explain in the context of the problem, that means for every 1 hour between the 6th hour and the 14th hour, we are selling 15 less pairs of shoes. Each hour, we sell 15 less shoes. Okay, moving on to 37. We have Bay's Pet Shop. The number of dogs, D, is initially 5 less than twice the number of cats, C. If she decides to add 3 more of each, the ratio of cats to dogs will be 3 to 4. We'll write a system of equations that can be used to find the number of cats and dogs Bay has in her pet shop. Or Bia. I don't know. Bay, Bia. Okay, so the number of dogs, D, is 5 less than twice the number of cats. So D is 5 less than twice the number of cats. Then they say if we add 3 more of each, the ratio will be 3 over 4. Well, a ratio is a comparison of two numbers, or a fraction of two numbers. So if I add 3 to the D value, cats to dogs actually, meaning the cats is the numerator. So add 3 to the cats first, and then the denominator will be 3 to the dogs. That's 3 over 4. So now I have my system of equations. Let's see if we could have had 15 cats and 20 dogs. Well, let's plug in 15 for C, 20 for D, and see if it makes the equation true. So 20 is equal to 2 times 15 minus 5. So 20 would have to be 30 minus 5, but 20 is definitely not equal to 25. So no, since we can say at least one equation is not true. Is not true. Finally, we'll determine algebraically the number of cats and the number of dogs. So to do this, we can do a little bit of substitution. We know the value for D here is 2C minus 5. So let's take the value for D and substitute it in for C in our system, our second equation in the system. So we'll have 2, whoops, start with our numerator here, C plus 3 over, and then the substitution, instead of D, I'm going to put 2C minus 5. Plus 3 is equal to 3 over 4. So simplifying a little bit, we have C plus 3 over 2C minus 2, because negative 5 plus 3 is negative 2. From here we can cross multiply. 3 times 2C minus 2. And C plus 3 times 4. Distributing, 6C minus...
Excuse the interruption. Alejandra Esquivia, please come to the front office. Alejandra Esquivia to the front office.
And now we need to group our C terms on one side, so I'll subtract 4C from both sides. Group our numbers on the other side. And dividing by 2, we see that there has to be 9 cats. So once we have 9 cats, we can substitute back in to get the number of dogs. Section off some work. We know dogs is equal to 2 times the number of cats minus 5. So the dogs would have to be 18 minus 5, and in this case, 13 dogs. So 9 cats, 13 dogs. And just for good measure, we can write that in, 9 cats, 13 dogs.